second semester, you know me already. You know how wicked I am and how I can fail students. So that is fine. How many of you failed last semester? Can I see by hands?
Please
No
come
hand is
again.
showing up. I
Please,
want
we
to
didn't get
know.
it.
Oh, you didn't
No,
get it?
I think we are about 17 for the
Pardon
June.
me? Pardon me? Come again.
I was saying if you can come again because we didn't get what you were saying.
Is it from the beginning or at a certain point?
At a point where you were asking about the last semester or so, some of us we just joined. We came in this.
Oh, yes. I mentioned that for those who are in their second semester, they know me already. So it is the new ones, the freshers who don't know me. You will know me when we meet at the exam hall. That's the only time we'll meet. Because looking at the schedule, the face-to-face, I wonder if I can make it. Because my schedules may not allow me to meet you face-to-face, honestly. I will see how best we can arrange to meet face-to-face. We will decide. We will decide them ourselves. Then we'll see. Because the dates I have seen for the face-to-face doesn't favor me. I have some programs to attend. So we'll meet. So I was saying that those who are in their second semester, they know me already and they know how wicked I am, how I fail students a lot. So they don't have any problem. They are prepared to face me squarely this semester. For those of you who are fresh, I fail students a lot, so you have to sit up so that you not fail. I can still see the iPhones. Now the iPhone is 2. So I don't even know who is iPhone 1 and iPhone 2. So we'll see. But, you are welcome. We are at peace here.
Yeah.
And then I believe we will enjoy our stay, our short stay here. So I was asking those in their second semester who failed my paper last semester to raise their hands for us to see them. And they refused to show up. So they should keep hiding. We'll get them. Esther, didn't you fail?
No.
Are you sure?
Yes, sir.
Hey, how come? Yo,
Okay,
that's
I
fine.
attended all your lectures.
Yo, I see. That's fine. So let's start. Please, can you see my screen?
No, please. No,
Yes.
sir, please.
No,
No.
please. Okay, it has come now.
Yeah, it
Yes,
has
sir.
come now.
Thank God. You don't mind me. Once you attend all my lectures, I don't think you can fail. It is only those who didn't attend my lectures that failed. So there is no cause for alarm. So we want to look at quantitative techniques for financial decisions. I'm Okrah. Your humble servant. Is it clear
Yes, sir.
from
Yes,
your
sir.
end?
But
Yes, sir.
yes, sir, but it's too small. I'm a little bit zooming.
So let me use the slide show and see if that will make it more visible. I think it is fine now.
I think it's
Better now,
better.
sir.
Nice. So we'll start with the uses, importance, and tools of quantitative techniques in decision making. Uses, importance, and tools of quantitative techniques in decision making. Please, we'll be doing some calculations. And so I expect that you have your pens and your books or papers, if possible, your calculators by your side, so that it will make things easier for us. Now, the complexities of the modern business operations, high cost of technology, materials and labor, as well as competitive pressures and the limited time frame in which many important decisions must be made, all contribute to the difficulty of making effective business economic decisions. These call for the need of decision makers to apply such alternative approaches as quantitative techniques. Now, in recent times, very few businesses, in recent times, very few business and economic decisions are made without the application of quantitative techniques. For example, a decision on the location of a new manufacturing plant would be primarily based on such economic factors, with quantitative measures as construction costs, prevailing wage rates, taxes, energy and pollution control costs, marketing and transportation costs, and related factors. An understanding of the applicability of quantitative methods to economic decisions is therefore of fundamental importance to any economics student. Now, these are the objectives of our study. Under this topic, we should be able to state both the meaning and importance of quantitative techniques. We must also be able to state the uses of quantitative techniques and identify tools of quantitative analysis. For your information, I don't hide my questions. My questions are not and will not be new to you. You know my questions before you go to the exam hall, because I don't fear who. Now, this is how, if you are serious, you get to know my questions. I set the questions based on the objectives of the topic. So whenever I'm ready to set the questions, I'll just come to the objectives and make sure that the questions will follow the objectives of the topic. So now you know how the questions will be, and you can see the questions already. I don't lie. So that is what I have said. So if I'm going to set my question, I'll just come to the objectives and set the questions in line with the objectives. And that is it. So you know the question. You now agree that you know the question before you go to the exam hall. Now let's look at the definition of quantitative techniques. What is it? Quantitative technique can be viewed as a scientific approach to what? Decision making, with special emphasis on the quantification rather than qualification of decision variables. So our emphasis is on the quantification, but not the qualification of the decision variable. To buttress this definition, let's consider the following management decision on pricing of a new product. So the XYZ company is in the business of manufacturing and distributing electronic equipments. And these equipments include radios, stereos, and so on and so forth. The company decides to make a new two-way citizens band identified as CB radio. The question here is, what should be the price of the new CB radio? So this is a decision we have to take. The XYZ company is in the business of manufacturing and distributing electronic equipment. These equipments include radios, stereos, and so on and so forth. The company decides to make a new two-way citizens band identified as CB radio. The question here is, what should be the price of the new CB radio? So this is a decision to take. Now, through market research or survey and comparison with other products, management agrees that the product could be priced between 60 cedis and 100 cedis and still compete effectively in the marketplace. So if this is the range that management has agreed upon, then it means that our prices should range within this boundary. So if that is the case, then we can reduce the choices to the prices of 60 cedis, 70 cedis, 85 cedis, and 100 cedis. So you see that these prices, these four prices are all within that range of 100 and 60 and 100. So no price is outside the range. Now, the decision-making process reduces the selection of one of these four prices. So what is the best price? That is the price that maximizes the profit of the company. So everybody does business to make profits. And in every situation, the businessman wants to make more profit. So whenever there is the opportunity to make a profit, you make sure that you maximize the profit. So that is what this XYZ company seeks to do. But much as you want to make profit, you must also make sure that you remain competitive in the business market. So this is where you have to take the best decision and to be able to identify the best price out of these four that we have chosen within the range. So that is the work we have to do. Now let's see what happens. Now, it continues to say that market research predicts that the quantities sold at the prices of 60 cedis, 70 cedis, 85 cedis, and 100 cedis would be 2,600, 2,200, 1,600, and 1,000 units, respectively. Now, the price, production, and cost schedules are given below, as you can see in this table. So we have the price represented as P, the quantity represented by Q, and the cost represented by what? C. Then we have the revenue represented by R. What we want to know is the profit. But as business students and business people, you know that by definition, profit is equal to what? Revenue minus cost. Profit is equal to what? Revenue minus cost for each price alternative. But we also know that revenue is a product of what? The price and the quantity. So revenue is equal to price times quantity. If you follow the table, this is how you get your revenue values. So if you multiply the price here, 60 by 2, the quantity, the price for alternative 1 is 60. The quantity, the unit quantity is 2,600. So if you multiply 60 by 2,600, you get the revenue here, 156,000. So that's what you do for all. So now you understand how these values were obtained. So for each revenue, for each alternative, you multiply the price of the product by the unit quantity, and that gives you the revenue. Now, if you take away the cost from the revenue, you get what? The profit. So that is what you see here for all of this. Any questions so far?
Yes, Doc.
Yes, sir.
Yes. As for the cost, is it always given?
Yes.
Okay.
But in this particular situation, if I'm setting a question around this, my question here is not going to be based on the calculation. We are just trying to take decision. We are trying to make a decision here, a correct decision that will maximize the profit of the company, XYZ company. So if I'm setting a question here, I'm going to give you all this information, and then I ask you questions from this information. That is what I will do. So for the calculations here, there is not necessary here at this point. But you need to understand how the values were obtained so that based on that, you can answer the questions that will follow. So the cost will be given. You'll be given the product, the price for each alternative, and then the quantity, the unit quantity, then you should understand that maybe if I'll leave something out, but in this case, like I said already, at this point, I don't need any calculation here. It is just for you to take a good decision from the data. That is all that we want to do at this point. So if there's any question coming from this area, it is about how you take a good decision out of this data before you. That is what will happen if I want to do something around here. So I want you to understand that by definition, profit is equal to what? Revenue minus cost. So that if you look at this table, you'll be able to follow. Then you should also remember that your revenue is a product of the price and the quantity. So this is how you got all these values here for revenue. The cost will be given, and then find the rest. Any other question? Janepa, no question. Thank God it's Saturday. Let's move on. Now, from the table, we observed that the best price is the price for which the maximum profit can be obtained. So let's go to the table and let's see which one is the best price. Look at the table now. Can you identify the best price that gives maximum profit?
Yes.
Yes. Who has seen it? Tell us.
The 85 cedis was giving us 30,000 profit. Is better than the 60, which is 15,000. The 70, which was giving 27,000. Then the 100 is giving 15,000 profit. So I think the 85 gave the best.
I see. Any alternative view? Any alternative view? Okay. So our sister says the 85. And I think I agree with her. So this price is the number 3 alternative number 3. Okay. But what did I write here? Instead of 85, I wrote 88 here. Accept now a critical. Instead of 85, I wrote 88. Okay, so we'll correct it. So that is 85 units. And that gave us the profit of 30,000 cedis, as she said. Now, the second best price alternative is the 70 cedis per unit with a profit of 27,000 cedis. Now, we do this on the following assumptions. Okay, the assumptions under which this solution is optimal are the following. 1, only the prices 60, 70, 85, and 100 cedis are possible. Do you agree with that?
Yes, sir.
Why do you agree with that?
It was based on the market research that was done. These are the prices that they came out of from the research that was carried out. For this price decision.
Aside that, yeah, we were given a range. We were given a range. And the range is 60 to 100. But we decided to settle on 60, 70, 85, and 100. So if you don't give the assumption, if you don't state the assumption, then somebody will come and ask you, if the range is from 60 to 100, and you have decided to choose only 4 prices within that range, whereas there are a lot of prices within the range which could have been used. Somebody could have used 61 cedis. Another person could have used 91 cedis. Another person could have used 99 cedis. How you chose to use, so if you just leave it blank like that, I will come and contest you, argue with you that, I don't think you've given us the best alternative. So that is why you must state your assumptions under which you are making your decision. I hope that is clear.
Yes.
Yes, sir.
Yes, sir.
All right. Then the next assumption under this is that the corresponding sales and costs are known exactly. Then the third one, the criterion is to maximize profit. The criterion is to maximize profit. So this is how we deal with this decision making. So one day, if I choose to set a question around this, I'll know how to address it, and you should also know how to address it. Thank God it's Saturday if there's no question. We have any question? Then I'm moving on. Now we want to look at the importance of quantitative techniques. The importance of quantitative techniques. Now today's scholar is even necessary at all in the study of business and entrepreneurship management. The thinking has been that this is a course to be worried about by students in economics and related studies. The truth is that today's business cannot do without some form of quantitative aptitude. Accounting principles are built on the premises of quantitative techniques. So also are production and pricing principles. Now, apart from the above, quantitative techniques are essentially valuable in the following areas of management decisions. 1, planning. 2, forecasting. 3, control. And 4, evaluation. So if you are a manager, as most of you are, these are the key areas you think about. You plan, you forecast, control certain things, and you do evaluation at the end of a certain period. And these are very, very important. And in all these things, you need quantitative techniques. So that is why quantitative technique is very, very important to you as a manager in your decision making. To be able to do all this, you need certain tools of quantitative analysis to be able to do this. Now, the basic ones are 2. We have the mathematical tools and the statistical tools. So these are the tools that you use the mathematical and the statistical tools. Now, it is the aim of our discussion to concentrate on the application of these tools. We want to concentrate on the application of these tools. Now, let's look at mathematical tools. What are they? They are used in developing mathematical models. So mathematical tools are used in developing mathematical models. The general approach to the development of mathematical models of economic decisions can be outlined as follows. 1, you have to formulate the problem. How do you formulate the problem? You do that by determining the variables involved and categorizing them into those over which you have no control and those over which you have control. Now, the latter are referred to as decision variables. Then you specify all relevant constraints, such as production requirements, cost, and the like. So that is the first thing you do. The second thing is to establish the criterion for optimality. The criterion for optimality. This involves the definition of an appropriate goal. Now, if you want to get an optimal solution, what do you need? It involves either a profit maximization or cost minimization. So anytime you are looking for optimality, it is all about what? Either you maximize your profits or you minimize your cost. Now, in maximizing profits, you need to control the cost by minimizing the cost. So that is what we refer to as optimality here. 3, you develop the model by determining the specific mathematical relationship which exists among the different variables. These are stated in the form of an equation or a set of equations. So that is where the mathematics comes in. And there we shall be doing the mathematics as needed. The fourth one is to perform the analysis. How do you do that? You do that by substituting the values of the uncontrollable variables in the mathematical model and determine the values of the decision variables, which lead to an optimal or a minimum solution. In practice, the development of a mathematical model should be strongly influenced by the objective for which the model is being constructed. So take note. Then we look at the statistical tools. These tools are complementary. They only come in to complement the mathematical tools. We know statistics can be viewed as the application of scientific model in the analysis of numerical data for the purpose of drawing inferences that are useful in making rational economic decisions. There are basically 2 types of statistics, as we know. We have the primary statistics, which involves the analysis of primary data, and then the secondary statistics, which involves the analysis of secondary data. Further classification of statistics includes descriptive statistics and inferential statistics. Now, what do we mean by descriptive statistics? This involves the collection, presentation, and characterization of a set of data in order to properly describe the various features of the given set of data. Then the inferential statistics involve those tools that are used in the estimation of a characteristic of a population or the making of a decision concerning a population based only upon sample results. Based only upon sample results. So this is what we mean by the uses, the tools, and the importance of what? Quantitative techniques. So this brings us to the end of the first unit of the first session. And in conclusion, we are saying that quantitative technique is a course to be worried about by students in economics and related studies. The truth is that today's business cannot do without some form of quantitative aptitude. Accounting principles are built on the premises of quantitative techniques. So also are production and pricing principles. Apart from the above, quantitative techniques are essentially variable in the following areas of management decisions: planning, forecasting, control, and evaluation. And in summary, I would say that this unit has provided you some background information on the study of quantitative methods. And in a nutshell, the following were the major information obtained from these discussions. 1, the quantitative technique can be viewed as a scientific approach to decision-making with special emphasis on the quantification rather than qualification of decision variables. So this is what we have discussed. 2, we have also discussed that quantitative analysis basically constitutes two tools: mathematical tools and statistical tools. 3, we have also discussed that the development of a mathematical model should be strongly influenced by the objective for which the model is being constructed. And statistical tools are complementary to mathematical tools. We have also discussed that statistics in general can be viewed as the application of scientific model in the analysis of numerical data for the purpose of drawing inferences that are useful in making rational economic decisions. So these are the things we have discussed in these few minutes. So we end this first unit of the first session. If there are questions, put them forward before I move on to this next unit of the first session. Ladies and gentlemen, come up with your questions.
I wanted to know whether we can get the slides.
Why not? The slides are for you. So I'll give it to you. I'll put it on the platform for you to pick, because there will be assignments and other things there for you to do. So I was about to do that. I should have done that before the start of the meeting, but I couldn't. So right after, I'll give it to you. Any other thing? Okay. Then I can move on to the next unit of the first session. Let me drop this one. and bring the next one.
Sorry, if I want to ask a question.
Yes, sir.
Hello? I wanted to know, is it possible? It's
Go
like
ahead,
the
please.
quantitative decisions is probably to maximize profit and minimize cost. Is it possible that upon all the decision and the planning, forecast, and all that, is it possible that both the cost will be, is it possible in the situation where the cost and the profit will be at par with each other? Have we have a situation like that? Is it possible to have a situation like that?
Then you, in that situation, you say you have broken even. So we have that situation. And if you break even, that is good because there's no loss, there's no profit. Thank God. It is only when there is a loss that we cry foul. But it is possible to get, it is also even possible to get a loss. As in business, you can lose. If you break even, we thank God. So whenever the cost and the proceed, the revenue, cost and revenue are the same, then you say you have broken even. So in that case, it is only your energy that has gone waste, but at least your capital is intact. So you say, hooray, I nearly lost, but I did not. So thank God. So it's possible.
Okay, sir. Okay.
Any other thing?
Yes, I want to find out from you. In assuming that a model is designed to achieve a particular objective, are there any other external factors that can throw the model away, whereby the exact objective for the model will not be achieved?
Yes, those factors are there. And if you remember when I was talking about the assumptions, I mentioned that. So if you don't, the assumptions are there to safeguard your model so that anything that will happen happens within your assumptions. So that is what protects your model. So if you don't put the assumptions there, there are a lot of external factors that can affect your model. But once you have your assumptions there, your model is supposed to work within that assumption. So your model is safe within that, your assumptions. That's it.
Okay, so I asked that question in the sense that when you look at the decision taken by the government to reduce the cocoa prices, because the prices in the world market begins to fall and they may not have, or they are not having enough money to pay the farmers. Notice that at the beginning, when they came out with the prices, they were very much, or based on the assumptions that they have set in, they come up with a particular price. But then you notice that the prices in the world market does not fall within the assumptions they have set. So therefore, they would have to come back and revise the price. So in terms of decision making, how does this actually affect the overall objective of the company?
Yes, they have accepted. If you listen to their communication, yesterday I was listening to the Minister for Agric. They have accepted that, yes, they said there's a loss, and the president has directed that the finance minister should look for a loan to pay for the debt. So there is a loss there, and that is a fact. So that is what happens when external factors affect your model. So that is a fact. It happens. Are we okay with that?
Yes, please. Yes, please. Thank you.
Yes, sir.
All right. Any other thing? Okay. Then we'll continue. I still see iPhone, iPhone. So you are scoring -1 already. Because I don't know you. So I can't award any mark to iPhone.
Hello, sir.
Yes.
So please, in taking some of these decisions, what is the margin you give to factors that are not under your control? Like sometimes weather, like what we just said, the cocoa price, this world market. So those things are not under your control. So is there a margin you give to those when you are deciding, especially on your price? Is there a margin you consider so that in case some of these things affect your decision, what is the margin you give to some of these before coming out with some of these decisions?
Yes, in everything you do, for us in the statistics and mathematics and statistics, we always what we call the margin of error. So anything that you do, you have to give the margin of error. So we sometimes take 5%. Sometimes we give 10%. It depends. So you have to keep the margin of error. And that is why you see in this, let's use this cocoa pricing issue. When the government is coming out with the prices, it is not the amount the government gets from the world market that is given to the cocoa farmer. It is a percentage that they give to the cocoa farmer out of the total amount. So they also make room for this kind of effects or eventualities, unexpected. So they make for that. It's unfortunate that this time around, it seems they have over-accumulated the debt for years. And so there's nothing they can do. That is the situation. The debt has been accumulated. It's just that the politicians don't say the truth. So each of them, the NDC and MPP, will continue to be using, as this has happened, those in MPP will capitalize on it and use it. Just as when the NDC were also in opposition, they also capitalize on certain things and use against. So it's a game they play, but among them, they know where the truth is. Just that everybody wants power. So they will only play on the minds of Ghanaians. And then we give them the power and then they do whatever they want to do with the power. That's all. But in critical analysis, we know where the truth is. So if we drop our political lenses, we know what is right. But when we wear the political lenses, then you hear the noise and the hula balloons around. So that's what we are doing. But we'll get there.
Okay.
So there's always a margin of error that you must give in everything that you do. All right, so let's move on to the next unit under the first session.
Hello, sir. Good morning.
You too. Good morning, Sam.
Please, this iPhone. Please, I'm Georgina Lawe.
So, right, why don't you put Georgina Lawe there and you are keeping iPhone? Because
sorry.
my records,
okay.
So change it and put, because if I'm taking records and I am seeing iPhone and I may not remember
I don't even know. I didn't even know that's the name I have there.
Georgina Lawe. You see,
so I'll change it. Thank you, sir.
Thank you.
Bye. Thank you.
Bye. Can we see the next slide?
Yes, please.
Yes, sir, my little small.
Yeah, I've not turned to the slide show yet. Let me go there. So we want to look at Unit 2 under the first session. And this time we want to look at Mathematical Tools 1. And this deals with equations and inequalities. So we want to start the mathematics here. Now, an equation is a mathematical model which expresses the relationship between variables. And then an inequality, on the other hand, expresses differences among variables. So in simple terms, where you see the equal sign in the model, in the expression, you see the equal sign. That is an equation. And if you don't see the equal sign, you see the inequality signs, the greater than, the less than, the blah, blah, blah. Once you don't see the equation sign, it means it is an inequality. So in simple terms, that is the difference. If it is an equation, you have to see the equal sign. If it is not an equal sign, then it means it is not an equation, and so it becomes an inequality. Now, although there are several types of equations and inequalities, depending on the degree of relationship, our major concern here is on linear and quadratic equations, as well as linear inequalities. So that is our concern. That is the boundary we have set for ourselves. That is our assumptions for this unit. So at the end of this unit, you should be able to explain what mathematical equations are all about and how to formulate them. You should also be able to state the business applications of linear and quadratic equations. And you should be able to recognize the linear equations that are applicable to business decisions. And 4, you should be able to formulate equations for the solution of simple decision problems. So you have seen the questions I've set under this topic already. So you know them. Thank God it's Saturday. So let's take them, linear equations and quadratic equations. Now, a linear equation in the variable x, for example, can be written in the form as shown, as you can see here. So this is a linear equation. You could see that there is no square on the x, on the variable x, there is no square. There is no cube. There is no, there's nothing. The only thing you see is 1. When it is 1, we don't write it. When the exponent is 1, we don't write it there. So if you don't see anything on the variable, it means it is 1. And so anytime it is 1, it means that is what? A linear expression or linear equation. Once I put 2 there, making it x squared, it ceases to become a linear equation, but a quadratic equation. So those are the differences. If it is 1, it is linear. If it is 2, it is quadratic. If it is 3, it is what? Cubic, but we are not going there. We have set a boundary that for our discussion, we are working within the boundaries of linear and quadratic equations and inequalities. So we are not going beyond 2 or the square. Now, from this model, A and B as you can see, are not variables. They are constants. So they are figures that you'll be seeing. You can see 2x, 3x, 4x. They are representing the A. Okay. So we call them the coefficients. Okay. So the number which multiplies the variable is what we call the coefficient of the variable. So if I put, so this A, you see AX, A is called the coefficient of X. So I can give you a simple question, give you this expression, and ask you to identify the coefficient of X. If I ask you to identify the coefficient of X, you should tell me the coefficient of X is A. If I give you 2X, and I ask you to identify the coefficient of X, you should tell me that the coefficient of X is 2. So that is what we mean by that. And B here is a constant. Both A and B are constants, but A is a coefficient of X, B stands alone, so it is fully a constant. That is a full constant. So A and B are constants, and A must not be equal to what? 3. Mr. Ture, do you know what we mean by 3?
Pardon?
0.
0.
Do you know what we mean by 3?
Yes. 0.
0.
I'm referring to Mr. Ture.
Yes, I'm here, Doc.
Yeah, I mean, I mentioned 3. Do you know what we mean in Ghana in our language, local language?
No, I don't. Unfortunately, I
Uh-huh.
don't. Yes.
That is 0.
All right, thank you. Thank you.
Free.
I'll record that one
So,
now.
so anytime you hear me mentioning 3, that is 0. I'm referring to
Yes.
0.
Yes. Okay, thank you.
All right. So linear equations are classified as first-degree equations. Unknown variables in a linear equation can be solved for using simple algebraic operations, as you can observe from the following examples below. So let's start with some examples. The first example is asking us to solve for the unknowns in the following linear equations.
Hello, sir.
Solve for, yes, sir.
This, when you say linear equations are known as first degree equations, what exactly do you mean by that?
Thank you. I like that question. When we say first degree, you see, when we write expressions, the degree of the expression, I don't want to mention the term so that I'll take somebody. I know most of you are anti-mathematicians. You are anti-mathematics, so I don't want to mention that name, but I'll just say as an expression. Now, anytime you see an expression like this, I believe you can see my cursor. Once you
Yes,
see
yes.
an expression
Yes.
like this, the exponent, or what is called the power on the variable, the highest exponent of the variable gives you the degree of the function or the degree of the expression. Okay. Now, what is the highest exponent you see here on the variable x?
1.
The highest power, 1. So the degree of this expression here is 1, or first degree expression. So because the linear equation, I earlier on mentioned that the highest power on the variable is 1. Whenever you have the exponent, the highest exponent on the variable being 1, you say the expression is a linear equation. So the degree of that linear equation is that is 1. In this case, this is 1. So the degree of any linear equation is a first degree linear equation. The degree of any linear equation is first degree, because the degree is, we identify the degree with the exponent, the highest exponent in that expression. And in every linear equation, the highest exponent is 1. And so once it is 1, it means it is a first degree equation. Have I made myself clear?
Yes, sir. Thank you.
Thank God it's Saturday. All right. So we have to solve for the unknowns in the following linear equations. So the first linear equation is 5x minus 6 equals 3x. 5x minus 6 is equal to 3x. We have to look for what? The unknown. And the unknown here is x. So indirectly, we are supposed to make x the subject. And I believe at your level, everybody here knows how to do change of subject. So this one is, once it is a linear equation, it is change of subject you have to do. Okay. For those of you who are anti-mathematics, let's look at this. So what do? You have to group like terms. Okay. So those with x will have to move and stay on one side, whilst those without x attached to them will also have to move to stay on the other side of the equal sign. Okay, I'm just using the layman's approach. I don't want to use mathematical statements here, because if I should use mathematical statement, I'll say subtract 3x from both sides of the equation. And the anti-mathematicians will not agree. They will not be happy with that. So I will not go there. So I want to use the layman's approach. So for the layman's approach, you make sure that those with x attached to them move to stay on one side of the equal sign, whilst those without x attached to them, that variable x attached to them, also move to stay on the other side of the equal sign. But in doing so, you take note and make sure that if you are a female, the rule is that if you are a female and you cross the equal sign to the other side of the equal sign, you cease to be a female. You become a male. If you are a male and you also cross the equal sign, you cease to be a male, but you become a female. What do I mean by that? The sign, the operational sign, will change once you cross the equal sign. So if it is positive and it crosses the equal sign to the other side, it becomes negative. If it is negative and it crosses the equal sign to the other side, it becomes positive. That is what I mean. So if you look at this 3x on the right side of the equal sign will have to move to join the 5x. But in doing so, you realize that the 3x here is positive. So once it crosses the equal sign, it changes to be negative. So that is what you see here. I believe you have seen it. And this 6 here is also negative. Once it crosses the equal sign to the other side, it becomes what? Positive. So that is what you see here. Are we okay with that?
Yes.
Yes.
Please, if you are here and you don't understand something, you should be the first voice I want to hear. We paid equal fees, so we must try to understand. Yes, I will see Kanashi. Ashi kra. Wankasa, Usikanashi. The kasa. If you have any concern, raise it, and let's see how best we can deal with that. So that is it. So now we've got into this stage where we have, that's what we mean. Once you do that, you say you are grouping items. So we have finished grouping the items, where those in skirt are at one side and those in tra are also on the other side. Then you see that you have 5x minus 3x. Okay. Now, if you subtract 3x from 5x, what do you have?
You have to
Get to 2x.
You get 2x. So that is the 2x you see here. I have skipped this step. I don't want to do any factorization there. It is factorization, and okay, let me explain that step. There are two ways. Either you go through that step, or you can also skip it and come to the third step. What I did at this stage is that I factorize, because I saw that x here, there's x here, and there's x here. So x is common. So I factored x out. And if I factor x out, here I'll be left with 5, and here I'll be left with -3. So that is what you see here. So I've not changed this. If I want to get this back, I only expand it. This times this will give me this. This times this will give me that. So it's one of the means you can do that. But if you do that, it clearly takes away the x's, and then you see 5 minus 3, and so you say 2. Then you now multiply the 2 by the x, and then you have your 2x. So it is the same. Yes, sir.
Yeah, is it always necessary to put either negative or positive sign there?
Come again, please.
I say, is it always necessary to put either negative or positive sign? Because, yes, that is when you have, like, if you want to subtract, if the answer is supposed to be like 5 minus 6, for example, if it gives you a -2, so will it be necessary?
No, it is not a matter of necessity here.
Yeah,
the issue is that
yes.
The issue is that we group items, okay? And I said, and I mentioned that in grouping items, once something crosses this equal sign, the operational sign on it will have to change. That one is compulsory.
Yes.
So from here, this in grouping items, we want all those with x attached to them to come to one side. So now you see that there's 5x here, and then there's 3x here. But both of them are on opposite sides of the equal sign. But we want to move one of them to join the other. Now, in moving, so we have to move 3x here to come and join 5x on the left-hand side. In doing so, once this 3x crosses this equal sign, the sign on the 3x must change. Over here, it is positive. Once it crosses the equal sign, the positive will change to what? Negative. That is why you are seeing negative here.
Oh, okay.
So it is that one. After that rule, it's a rule that you have to follow. So it's necessary. It is compulsory.
All right, thank you.
Thank God it's Saturday. Then, if we are okay with that, then you now have to, after you have grouped. Yes, sir.
But because wedding was here.
Your class no wedding. So yo, and it's 150 for you. What? Okay. So after you have grouped the items, then you need to what? Simplify. What do we mean by simplifying? If you have to subtract, you subtract. If you have to add, you add. If you have to multiply, you multiply. If you have to divide, you divide. That is what we mean by simplification. So we now subtract 3x from 5x, and that gave us 2x. Now for this 6, it's a loan, so we maintain it. So that's what you see. Then don't forget that we are only doing change of subject. We are trying to make x the subject. So at this stage, we need x, but not 2x. So what do? You have to remove the 2, which is attached to the x. That's what we are referring to as the coefficient of x. We want to remove the coefficient of x so that x will stand alone. How do you do that?
By dividing both sides by 2.
It is. Thank you very much. So we divide both sides of the equation by 2. So we are going to divide 2x by 2, and that's what you see here. And also divide 6 by 2. And so that's what you see here. Now, when you do that, the 2 here will cancel this, and you are left with the x standing alone. And these 2 will also divide this 6, and you have 3. So you say our x is equal to what? 3. Now we have found the unknown, because the question says we should solve for the unknown. And now we know that, oh, not knowing this x is 3. Are we okay now?
Yes, sir.
Any question?
Yes, sir.
Yes, if you have any question, ask. No question. Thank God it's Saturday. Zenepa, no question. Then we come to the second example. The second example, which says that we should find the unknown in this expression. And here, the unknown is P. It is this P that we don't know. So it means we are going to make P the subject. That is all. But there is something in brackets. So the first thing to do is to remove this bracket. How do you remove the bracket? You remove the bracket by expanding this bracket. So you use the 2 outside to multiply P, and use the same 2 outside to multiply 4. So you use the 2 outside to multiply everything within the bracket. That is what we mean by expansion. Once you do that, you see that the bracket will vanish. So that is what you see here. So 2 times P gave us 2P. The same 2 multiplies 4, and that gave us 8. So you see that we have removed the bracket. We no longer see the bracket expansion to be done, so we maintain it. So that is what you see. Then from this stage, you see that we have gone back to the previous example where we group items. So if you truly understood this example, then you can ask me to just go on and skip this. Can I skip this?
Yes, you can skip, please.
Are you sure? Everybody wants me to skip. If you don't want me to skip, tell us so that we continue. Can I skip? Silence
Yes,
means
sir.
caution.
Yes, sir.
You keep quiet and be there. Then you have the third example. Still, we are looking for the unknown. We are still looking for the unknown. So the unknown here is x. So it means we have to do everything possible to make x the subject. We need to do everything possible to make x the subject. Now, you see, there are some divisions here. 7x plus 3 divided by 2 minus 9x minus 8 divided by 4 equals 6. When there was bracket, we removed the bracket before we don't want to see anything over anything. No, everything should be straightforward, inline. So where you have division like this, the first thing to do is to look for the LCM, the lowest common multiple or the least common multiple. Okay, now so you have the denominators to be what? 2 and 4. What is the LCM for 2 and 4? That's the first thing you have to think of.
4.
So what's the LCM for 2 and 4?
4.
4. Do you all understand? Do you all remember your LCM? You see that the mathematics you learn in the primary school hasn't changed. Mathematics doesn't change anywhere. It is the same thing. That's why when I see people running away from mathematics, I laugh, because it doesn't change. It is the same thing from the primary school. You only build upon it, add something small, that's all. So it is the LCM from primary 3 that we are talking about here. So the LCM for 2 and 4 is what? 4, as you have said. So what do we do with the 4? Once you find the LCM, you use that LCM to multiply everything in the given expression. You use the LCM to multiply everything in the given expression. So we are going to multiply this 7x plus 3 over 2 by 4. That's what you see here. So you see that we have multiplied 4 by 7x plus 3 divided by 2. You do the same to 9x minus 8 over 4. So you see we have multiplied it by 4 here. That's what you can see. Then you do the same to 6. So you multiply 6 by 4. And that's what you see here. Once you do that, you see that these 2 will cancel out. So 2 will cancel itself and cancel 4. And 4 will now become what? 2. Because 4 divided by 2 give you 2. Good. So that's what you see here. Okay. So you see that the division has vanished. Then you come here, do the same thing. 4 divided by 4 will give you 1. And that's the one you see here, multiplying the bracket there. So the division has also vanished here. And then 4 times 6 gives us 24. So that's what you see here. Then at this stage, once you have gotten to this stage, then if you truly agreed with me to skip this stage after we expanded, then you must be able to continue. But this time I will not allow you to continue. Unless those who have not understood, but they are feeling shy to tell us, we'll be killing them. So once you do this, you are left with this, the expansion. So we've gotten back to this example 2, where we expanded. So it is the same thing we are going to do here. So you expand. So you use the 2 to multiply everything inside this bracket. You come here, you use the 1 to multiply everything inside this bracket. So that's what we are going to do. And please, ladies and gentlemen, watch out. Wherever you see the negative before the bracket, it is dangerous. You need to breathe in. Stop, breathe in and out before you continue. The negative sign is the most dangerous operational sign in mathematics. And we love it. So anytime we have certain questions, we always want to bring the negative sign there, because that brings out the mathematics in you. If you are able to make good use of the operation sign, it brings out the mathematics in you. There is mathematics, there's a lot of mathematics within you. So we want you to bring them out. So watch out. I'll show you how to handle it. Now, so in the first bracket, if we expand, then 2 will multiply 7x, and that gives us what? 14x. So 2 times 7, 14. Then you attach the x. The same 2 will multiply 3. You get what? 6. So that's what you see here. Now let's come to the danger man. The dangerous man here, negative. Now when you come here, this is what you do. You don't take the 1 alone to multiply the bracket. No. You must take it together with the sign there, the negative sign. So you say negative 1 times 9x, so that it gives you negative 9x. Then you say negative 1 times the next one there, -8.
So give it
What do you get?
positive
-1
8.
times negative.
Positive 8.
That gives you +8. Are you okay with that? Any concern?
Yes, sir.
Yes, sir. Yes, sir.
Are there any concern?
No, sir, for now.
Yo. Yo. So we have finished with this. But let me show you something. Why that negative there is dangerous. Now, if you don't take the negative, if you don't take the 1 with the negative along, if you don't take it along with the negative, this is what is going to happen. Assuming you just say 1 times 9x. So you are going to get positive 9x. So you have positive 9x. But in that case, you are only going to copy the negative. You just write the negative down, and then you say 1 times 9x. So you have -9. Mostly, it doesn't affect the first term in the bracket. But when you go to the second term, that is where the danger comes. So now, because you did not take the negative along with the 1, you would have said 1 times -1. And that would have given you -8 here. So this is where your solution would have been wrong. Is that clear? So be careful.
Sir.
Always go along with the negative sign when you are expanding the bracket. Then in that way, we'll all be safe. So at this stage, you only group like terms. Those with the x stay at one side of the equal sign, and those without x also moves to the other side of the equal sign. Now, we have 14x and -9x on this side. Here, the sign on the -9x or the 9x will not change because it has not crossed any equal sign. It is on the same side, so you are not going to change the sign. But look at 6 and 8. They are going to cross the equal sign to go and join 24 on the right-hand side. So once they are positive and they are crossing, they will all change to negative. That's why you see negative, negative. Are we okay? So that is it. Then 14x minus 9x gives us what? 5x. And the right-hand side, 24 minus 6 will give you 18. 18 minus 8 will give you 10. So that's what you see here. So now we have 5x equals 10. But we don't need 5x. We are looking for x. So we have to remove the 5 from the x. How do you do that? It is multiplied. And so we have to divide everything by the coefficient of x by 5. So that is what you see. So you divide 5x by 5. That's what you see here. Divide 10 by 5. That is what you see here. Now 5 cancels 5. You are left with your x, and that is what we want. Then 5 divides 10. And you have 2 as your answer. Any question? No question, eh? Are you sure there are no questions? If there's no question, we'll move on. Now, ladies and gentlemen,
please, there is a question.
Yes.
Sir, please,
Go
how
ahead.
did you arrive at the -6 before the -8, please?
Mr. Osai, will you stop writing on my screen for me? Write on your paper, on your book, in your book, not on my screen. Yes, madam. Come again.
Please, yes, please. This is Georgina. I want to find out why we had the -6 before the -8.
But are you okay with how we got the -8?
Yes, please.
Are you sure?
So you kindly explain that portion to us, please.
Because if you tell me that you understand how we got -8, but you don't understand how we got -6, I would have been surprised. Okay, so this is what happened. You see the 6 here is positive, and it crossed the equal sign to join the 24 on the other side. If you remember, the rule says if you cross the equal sign, your sign, the sign on you will change.
Yes, please.
If you are a female, you become a male. So
Yes,
the
please.
6 here, before crossing, it was positive.
Positive.
So once
Okay.
it crosses, it becomes negative.
Okay. Okay.
The same applies to the 8. Are we fine now?
Yes, sir. Thank you.
Are you okay? Thank God it's Saturday. Any other thing? All right. If there's no question, I was saying that per our discussion from the beginning, we said that our interest is going to be on the application of these equations and inequalities on business terms. So now that we have refreshed our memories on these equations, we now want to apply this in a business sense. So now let's move on to the applications. And so to be honest with you, if I am setting questions, the questions, I'm not going to give you find the unknowns on this equation. I will not do that. So that one is just a matter of practicing it too, because you are going to use it in the applications. So that's what I've started from there. But my questions will be application questions. To be honest with you, that's the truth. So don't expect anything like this. That find X here. No, I'm not going to do that. So got the application questions carefully. The first example here is saying that XYZ company produces product A for which cost, and when we say cost, once you are a company and you are doing production, when you mention cost, you know that it includes two things, labor and material. So this cost for producing product A includes labor and materials. And so the cost is 6 cedis per unit. That's the unit cost. Then we have fixed costs to be 80 cedis. Now, each unit is sold for 10 cedis. Determine the number of units which must be sold for the company to earn a profit of 60,000 cedis. So this is an equation. So this is the application question for all the equations that we have looked at. Okay. So this is what you see. So it is up to you.
Each unit, you multiply the first unit. The number is 60.
Mute yourself, sir. All right. So when you have the application, the most important thing is to deduce the expression, the equation from the application statement that has been made. So this is how we go about it. Once we are talking about profit, then you should also know, remember your formula for profit. We know that by definition, as we started this morning, profit is equal to what? Revenue minus cost. Thank you. So that is what you see here. But mathematicians, you know, we don't speak or write English. We speak and write symbols. So out of this English that we see here, we move them away from English words and go to symbols. So we put P to represent profit,
Profit.
R to represent revenue,
Revenue.
and C to represent cost. So
cost.
this now becomes P is equal to R minus C. Okay. So with that expression, you see that we have started with the equation. The equation is coming in now.
F.
Then let us represent the level of output. Let X represent the level of output, so that we'll say that total cost, which is C, is also represented by fixed cost, okay, plus variable cost. Okay. Total cost is equal to the fixed cost plus the variable cost. So the fixed cost we are representing by what? FC, and the variable cost we are representing by VC. So we have C, which is the total cost, is equal to the fixed cost plus the variable cost. So C is equal to FC plus VC. Okay, if you look at the question, all these things are stated there. You have the fixed cost to be 80,000. So where you see FC, you put 80,000.
FC is equal to 80.
Okay. So it follows that profit is equal to revenue minus cost. And the question gave us the profit to be what?
80,000.
Good. So that is what you see here. That is what I've put in place of P. That's profit.
So,
now,
and then
the revenue.
P is equals to 60,000.
The revenue, it says what? Each unit is sold for 10 cedis. Each unit is sold for 10 cedis. So you have, we don't know the total, the number. So we don't know that number. Determine the number of units which must be sold. So that is the X. That's what we are representing by X. Because we don't know it. We are representing the unknown by the variable X. You can choose to represent the unknown by any of the letters of the alphabet. Somebody can represent it by Y. Somebody can choose to represent it by P. Somebody, anything at all. But make sure that the variable you are using has not been used already. Okay. So we know that each unit was sold for 10 cedis, but we don't know the number of units which were sold to earn the profit of 60,000. And it is that number that we are looking for. So it is that number we are representing by X. So that if we multiply that X by 10 cedis, then that should give us the profit of what? 60,000. So that is why you are seeing 10X here for the revenue, because each unit was sold for 10 cedis times the number of units that we don't know, and that number is the X. Are we okay with that point?
Yes, sir.
All right. Then we come to the cost, and we say the cost is made out of two things. We have the fixed cost and the variable cost. The fixed cost, the question gave us to be 80,000 cedis. But the variable cost, we know the cost per unit, but the number of units we don't know. That is what we have represented by X. So we have to multiply the X by the amount per unit, which is 6 cedis. So that is what you are seeing here. So that's why you see 6 times X here. Ladies and gentlemen, are we on the same page? Yes, I can see Mr. Ansan, your hand is up.
Yes,
Go ahead.
I am not clear. Yeah, thank you. I'm not clear with the X because we have 10X and the 6X. Can you explain that part a little bit? Those two
Thank
X
you.
have got us to, that's my concern.
Thank you. That's a nice question. We have stated that the X is the unknown number of items, the unknown quantity of items that were sold in order to get the profit of 60,000. Are you okay with that?
Yes, sir.
So this X, which is multiplying the 6, and the X multiplying the 10 are the same. Are you okay with that?
Okay.
Because that is what we are going to look for. We don't know it. So that's what we are looking for. So now our equation is getting set.
Hello, sir, sorry. So the 10 is the point, the X is the 6 means, that was with the question. But see, I'm not still clear about it. You have the
Please
10
come
X.
again.
I'm still not clear with the X. Yeah, the X, the 10.
No, we are saying we are saying that the X is the unknown. You say determine the number of units or quantity of units which must be sold for the company to earn a profit of 60,000. So it is that number they say we should determine. That is what we have represented by X. Now, let me come to your point where you don't understand the 6X and the 10X.
Yes.
For you to get this amount of profit, it is based on what? The unit price times the number of units sold. Okay, so when you come to the cost price, each of the items that were sold were maybe bought, or in terms of production, the company spent 6 cedis on each of them. 6 cedis to produce each of them. Are you getting that point?
Yes, sir.
For each unit, for each item, the company spent 6 cedis to produce it. Then, in making revenue, it sold each item for 10 cedis. Is that correct?
Okay. Yes, sir. Yes, sir. Yes, sir.
The company spent 6 cedis in producing each item, but sold each item for 10 cedis. But the question is, we don't know how many items the company produced in order to get a profit of 60,000. So it is that number of items, the quantity of items the company produced. That is what we are looking for. And we don't know it. That is what we have represented by the variable X.
Okay,
Are you
sir.
okay now?
Yes, sir. Yes, sir.
So if that quantity is represented by X, then for us to know the total cost of production, we have to multiply that quantity by 6. So anytime you are looking for the cost of production, you multiply by the cost per unit, which is 6. So now we know the total number of items produced is X. So 6 cedis times X will give us the cost of production. And then when we come to the revenue, each unit or each item was sold for 10 cedis. So if you want to know the total revenue, we have to multiply what? The total number of items, which is X, by 10 cedis.
I get it, sir.
Thank God it's Saturday. Are we all okay with that point?
Yes.
Yes, sir.
Okay. Zenepa yento aso. So that is how we arrive at 6X and 10X. With 80 cities. So now we know the total revenue stated in the equation 60,000. So that's our, total profit stated in the equation 60,000. So that is our P. When we come to revenue, each item was sold for 10 cedis. And so we multiply 10 cedis by the number of items produced, which we don't know and we have represented by X. So 10 cedis times X. We come to the cost, which has fixed cost stated in the equation to be 80,000 plus the variable cost, which is 6 cedis per unit, times the total number of items produced, which is X. So that's how we got the 6X. Now you could see that our equation has taken shape. Okay, so we are now to find this X. That is all. Now, ladies and gentlemen, we have to remove the brackets. How do we remove the bracket? You see, you must always, yes, somebody is talking, talk to us. Let's hear you. Go ahead. So we are listening. Oh, well, she says she will not talk again. No problem. So we have to remove this bracket. How do you remove this bracket? Now, there is one here. You see, in mathematics, that is what we used to confuse you people sometimes. Those of you who don't like, who say you don't like math. Unfortunately, what pains me is the fact that those who run away from mathematics are those who practice mathematics every day. If you ask the person to come and look at math, I don't like math. But he's the best person practicing it. So once you don't see, there's a bracket here. Once you don't see any other number, like 2, 3, 4, 5, 6, it means the number, there's a number there, and that number is 1. If it is not 1, whatever it is would have been written. And once nothing is written, it means it is 1. And if it is 1, mathematicians, we don't write it. But when you are doing your work, you must always remember that there is 1 there and you have to apply it. And so it's going to be what? -1, like I told you. You have to take the 1 together with the sign, the negative sign. So you say -1 times 80,000. And that is how you got -80,000 here. The same -1 times positive 6x. And that is how you got -6x here. Are we okay with that? So it is this same expression I have turned this way. If Kofi is equal to Ama, then indirectly Ama is equal to Kofi. So this is Ama, this is Kofi. So Kofi is equal to Ama, and so Ama is equal to Kofi. So this and this are the same. Nothing has changed, as you have seen. I've already interchanged their positions. So I brought this to the right and this goes to this. That's all. So there's no confusion there at all. So the expansion has been done, and this is what we have. Then we have to group items. So those with X will stay on one side. Those without X will move to the other side. So over here, this 80,000 will have to move to join the 60,000 on the right-hand side. But this 80,000 is negative here. So when it moves to the right-hand side, it must be positive. That is what you see here. R for this -6, it hasn't crossed any equal sign, so the sign cannot change. That is why you still see the -6 there. Ladies and gentlemen, any question on that point? Silence means consent. All right. So from here, 10x minus 6x will give us 4x. 60,000 plus 80,000 will give us 140,000. Then we need x, but not 4x. So what do? We divide through by what? 4. So we divide 4x by 4, and so that's what you see here. We divide 140,000 by 4, and that is what you see here. Now 4 cancels 4, you have X. 4 divides 140,000, we have 35,000. So X is equal to 35,000. But what is X? X is the quantity or the number of items that were sold. And so, therefore, 35,000 units must be sold in order to earn a profit of 60,000, because that is what the question is asking us. The question says, determine the number of units which must be sold for the company to earn a profit of 60,000 cedis. And so that is what we have done. Are there any worries? Any worries? Don't like the silence. Are there any worries? No worries. Okay, so we continue. So this is another example.
Hello, sir.
Yes, madam.
Yes, please. It's almost time for break, so I don't know if you can break us.
For break.
Yes, please.
Don't worry. I want to finish this slide before I'll allow you for the break. Then we'll
Okay,
go and
sir.
come back and finish up.
Okay,
So don't
sir.
worry at all. Let's finish this slide. When we come back, we take the third slide and then we go home and go and sleep. A total of 10,000 cedis was invested in 2 business ventures. A total of 10,000 cedis was invested in 2 business ventures, A and B. At the end of the first year, A and B yielded returns on the original investment of 6% and 5.75% respectively. How was the original amount allocated if the total amount earned was 588 cedis, 75 pesos? Okay, a total of 10,000 cedis as your capital was invested into a business venture, into 2 business ventures, into business venture A and business venture B. At the end of the first year, the business ventures A and B yielded returns on the original investment of 6% and 5.75% respectively. How was the original amount allocated if the total amount earned was 588 cedis, 75 pesos? So, what do we do? So this is all application of equations. So we have to turn this into an equation and solve for the variable. So we let X be the amount invested at 6%. So if X is the amount invested at 6%, then what will be the amount invested at 5.75%? So if the total capital invested is 10,000, and you know that X represents the amount invested at 6%, then for you to know the remainder of the amount invested at 5.75%, what do? You only need to subtract the X from the capital 10,000. Because out of the 10,000, you have invested X at 6%. So for you to know the remaining of the 10,000, you have to subtract the one you have invested at 6% from the total, which is 10,000. So that is what you see. 10,000 minus X was invested at 5.75%. Do you agree with me?
Yes, sir.
Who doesn't agree? That is what worries me. They don't agree, but they will not say. As to whether,
Sir,
yes,
sorry,
yes, sir.
please, can you go over it for the last time? I can't go over like the
No.
X.
Yes, in mathematics, anything we don't know, we will represent it by any one of the alphabets. Okay, but we mathematicians always like the X and the Y. So anything we don't know, we either represent it by X or a Y. So in this case, 10,000 cedis was invested in two different ventures. So you are holding your 10,000 and you decide to invest it in two different ventures, venture A and venture B. Okay. Now, you have attached percentages to them. So you invested part of the 10,000 in venture A at a rate of 6%. Then the remaining one, you invested in venture B at a rate of 5.75%. So if you don't know the amount you invested in both ventures, and you have decided to represent the amount you invested in venture A by X, then how do you know the remaining amount that you invested in venture B? Once you have identified that X amount was taken from the 10,000 to be invested in venture A, then the remaining one must be what? 10,000 minus what? The X that you have taken from the 10,000 to invest in venture A. I don't know if I'm making sense. Let's assume, let me use figures. So assuming the total is 10,000, you take 2,000 to invest in venture what? A. How much is left for you how do you know the amount left to invest in venture B? You only subtract the 2,000 that you have taken to invest in venture A from the 10,000. So that will be what? 10,000 minus 2,000. So that's what you see here. So it is that 2,000 I'm representing by X. So if I invest X from the 10,000 at 6%, then to know the remainder, I have to subtract X from the total, which is 10,000, and invest it at the rate of 5.75. So that is the meaning for the 10,000 minus X. Are we okay?
Yes.
Thank God it is Saturday. So the interest earnings are therefore what? 6% of X plus 5.75% of what? 10,000 minus X, giving us the total amount. Okay. Now we know X amount was invested at 6%. So 6% of X will give you the earnings for that one. Then 10,000 minus X amount was invested at 5.6%. So 5.75% of 10,000 minus X. And in mathematics, off means multiplication. Off means multiplication. So if you want to know the interest earnings for each of them, then for the first one, 6% of X. And then the second one will be 5.75% of the 10,000 minus X. And that will give us the total earning. So you add them and you get the total earning. Okay. Now, 6% of X. Now, percentage, any time you see this percentage sign and you want to remove it, you don't want to use the sign, you want to remove it. It means 6 divided by 100. The percentage means, percent means out of 100. Okay, out of 100. So divide by 100. So 6% means 6 divided by 100, and that will give you 0.06. If you have your calculators by you, divide it. Then off means multiplication. So this becomes 0.06 times X. because 6% of x is the same as 0.06 times x. I've taught you how to get the percentage. Divide it by 100, then you get this. This one must also be what? 5.75 divided by 100, and that is what gives you this. Then you multiply by 10,000 minus x, that gives you this. Okay. So when you put this together, you should get the total amount end. Okay, so you equate it to what? The total. So it follows that 0.05 575 times 10,000 minus x, 88 cedis, 70 equation. So the challenge is how to arrive at the equation. That is the challenge. So that is what we have looked at, and you must practice and be able to do it. So from here, it's just expansion, remove the bracket, group items, and then we solve. So you see, I have removed what? The brackets from here. This multiplies 10,000, and the same thing multiplies negative x. So that is what you see here. So the bracket is gone. Then what you do? You group items. So those with x will stay on one side, as you can see. So this and this are staying, but this 575 will have to move to the right-hand side. It is positive here. When it gets here, it becomes negative. So that's what you see. Then you subtract, and then this is your result. You have 0.0025x being equal to 13.75. We need x, but not 0.0025. So what do? You divide through by what? 0.0025. So that is what you see. Okay. Then you have your x to be what? 5,500 cedis. So if x is 5,500 cedis, 10,000 minus x will be what? 4,500 cedis. So these were the amount invested. That is the question we were asked to solve. Any question here before we go for break? If I want to finish the slide, we can go. So I want to end here on equations. Then when you come back, we look at quadratic equations. If we have more time, we can take the 10th slide. Any question before we go on break? All right. It is 11 after 10. How many minutes is the break? Is it 30 minutes?
30 minutes, sir.
All right. So we are supposed to be back by 10:41.
41. Yes, please.
Break time. Yes, 10:41. So go for your break and let's come back. Exactly 10:41 we start. We will not wait for anybody.
Okay. Okay.
Bye-bye.
Just one.
It is well.
It is well. It is well.
On the platform. Someone check and send the information for FMP 10 on the platform.
I'll send him.
Hello.
Hello, team. Hello.
Please, we are on break. 30 minutes break.
I just joined the lecture. I don't know, but do we have the slides
It will be given later.
to be given later?
Yes, please.
I have another class, so I'm just moving between the two. When I return, is it 10:30?
10:41.
10:41. Okay, but I'm sure I'm on the right. Listen, MSc Finance, yeah, January
Yes,
intake,
boss.
right? Yes. Okay, thank you.
Thank you.
So if you take the first bracket, you look for the common term. You have x squared minus 3x. So what is common to them? Tell me. X squared minus 3x in the first bracket. So x is common. So you take x out. So that's what you see. I took x out here. Okay, now the x you take out, you use it to divide everything in that bracket and put the answer inside the bracket. So there was x squared minus 3x here. I took x out. Now I'll use this x to divide the x squared. So you have x squared divided by x. What do you have?
X.
You'll be left with x. So that's the x I place here. Minus 3x divided by x. What do you have?
3.
3. So
Yes.
you have negative 3, not 3. So be careful with the signs, because the sign can cost you. You have negative 3x divided by x. So you should get negative 3, not 3. So that's why you have negative 3 there. So that's the minus 3. Plus, you go to the second bracket. Look for what is common to the second bracket. 4x minus 12. What is common there?
It's 4.
4.
What I mean by the common thing is the thing that can divide both. You have 4x minus 12. What is common to 4x and 12?
4.
4. So you take the 4 out. So that's what you see outside. Now use the 4 to divide everything in that bracket. So you have 4x divided by 4. What will be left?
X.
So you have x. That's what you see there. Then minus 12 divided by 4. What do you get?
Minus 3.
Minus 3. So that's what you have in the bracket. This will be equal to 0. Now take note. You realize that the answer you get in the first bracket is the same answer you get in the second bracket, isn't it?
Yes, it is.
Yes.
So I always advise my students to take time in getting the correct answer in the first bracket. Once you get the correct answer in the first bracket, you must always remember that the second bracket, the answer in the second bracket must be the same as the answer in the first bracket. So take note of that. Now that you are finished with the factorization, you see that the answers in the two brackets are the same. So you pick one of them. So I picked the first one because they are the same. So x minus 3 and put it down as one of the answers. Then open a second bracket and put those outside the brackets inside that second bracket. So I come and pick the x which is outside here and put it in the second bracket, plus the 4 outside here since it is positive, so plus 4, and I put it in the second bracket, equated to 0. That is your answer. Are we okay with the steps? Any question?
No, sir. No, sir. Sir,
Can you please go over?
a little bit over again, sir. Then, like, especially that in place of x, the fact that we write in place of that term. Yeah, that's
Very well. Very well. So I'm taking it all over again. We are to solve this quadratic expression. By the way, we've not finished with the solution. No. We are to solve. So if they say you should solve, it means we have to look for the values of x. So let me conclude this first before I go back and go through. Now, so at this point, you equate each of the brackets. You take each of the brackets and equate it to 0 and make x the subject. So if you take the first bracket and equate it to 0, you are going to get x minus 3 is equal to 0. Then you make x the subject. So x will be equal to what? Positive 3, because the minus 3 will cross the equal sign for you to get 3. You do the same for x plus 4, equate it to 0 and make x the subject. That will give you your answers. So that is what you see me doing here. So x minus 3 is equal to 0, or x plus 4 is equal to 0. We take them one by one. So if x minus 3 is equal to 0, then it means x is equal to 3. And if x is equal to 0, then x is equal to negative 4. So therefore, the solution is what? 3, negative 4. And that is the solution set. So anytime they say solve, they are asking you to find the values of x. So this is the solution. Now let's go back and go through step by step again. You have to solve this. So I said, before you start, look for the coefficient of x squared. Take it, use it to multiply the last term here, which is negative 12. So this figure here is 1. We agreed that it is 1. So 1 times negative 12 will give us negative 12. You don't write it. You imagine it in the air, but you make use of it. So it's negative 12. I wrote it here for you to understand what I am doing. But when you are solving a question, you don't write it. Then after you know this, you look for two numbers that when you multiply those two numbers, it should give you negative 12. That's what we call the product term. But when you add those same numbers, you should get the sum term here, which is 1. And we agreed that the two numbers are negative 3 and positive 4. Then I told you, once you get those two numbers, just attach x to them. So that's what you see. I attach x to negative 3 and I attach x to positive 4. Now you take these two, go and copy the same expression with the exception of the one in the middle we are calling the sum term. In place of the one in the middle, put those two numbers with the x attached to them there. So in place of x, this x in the middle here, you put negative 3x plus 4x. Why plus? Because the 4x is positive. So plus. If it were negative, you would have said negative 3x minus 4x. But it is positive. So you use what? Plus. So that is what I did here. Then after that, you put them into two pairs of brackets. So the first two, you put them into one bracket. The next two, you put them into another bracket. Then you begin the factorization. Look at the first bracket. Look at what is common in that first bracket. The first bracket contains x squared minus 3x. What is common in this?
X.
It's
Yes,
X.
we said x is common because, so now you take that common one out. So you put it outside the bracket. And then you then go back and use it to divide everything in that bracket. So you have x squared divided by x. And that gives us x. So we put it in the bracket. Then we have negative 3x divided by x. And that gives us negative 3. So that's what we put in the bracket here. We move to the second bracket, plus what is common? We have 4x minus 12 in the second bracket. What is common?
It's 4.
Hello?
Yes, sir, it's 4.
So you put the 4 outside. Yeah, so you put the 4 outside the bracket and go back and use that 4 to divide everything in that previous bracket. So we have 4x divided by 4, and that gives us 4. Then minus 12 divided by 4, and that gives us negative 3. That should be equal to 0. Now you see that the two brackets, the answers in the two brackets are the same. So you pick one of them and keep it here. And then you open another bracket and put those outside the two brackets inside the new bracket you have opened. So you have positive x here plus 4. So you keep it there. Then you equate the two brackets to 0. So this is how we arrive at this. Then you then equate each of the brackets to 0 and make x the subject. And then you get the actual values for x. Are we okay now?
Yeah.
I believe you are recording me too.
Yes.
Yes, please.
Okay, that's fine. That's fine. When you are revising, you can play the audio along, then follow. So that is fine. So if there's any question, let's ask. If not, we continue. I think I need to slow down. The way I wanted to go, I have to slow down so that, because so maybe we may not finish the second unit, but it's better to slow down for everybody to understand than to rush for nobody to understand. So we do what we can do, then we leave the rest to God. Any question? Or if there is no question, it means you can answer any question similar to this. Thank God it's Saturday. You need to practice these things. You don't practice with your hands. Mathematics, we don't read. You don't read mathematics, you practice with your hands. Yes, Mr. Ansa, your hand is up.
Yes, with the ones, please, can you go back the slide? Can you go back one slide?
Yeah.
Yeah.
I've gone back there.
What you? Yes, thank you very much. So with the into the bracket, so it means that this one, it means the x minus 3, and we should get the same answer in both sides. That is that we have the x into bracket. Okay.
Yes,
so
if you
should get that. The answer should be the.
Yeah, the answer should be the same. If you get a different answer, it means there is something wrong. It means you have made a mistake somewhere. You have to go back and correct it. Is that clear?
Yes, sir. Very clear.
Yes, iPhone. You see, you mentioned your name to me. I've forgotten. Go ahead with your question. iPhone.
Yes, sir. This iPhone is Gina. Georgina.
Gina.
Oh, no, it's a mistake, please. A mistake. Let's box on, sir.
All right. All right.
Oh, thank you.
Welcome. Okay. So let's take the next example. The length of a shop. The length of a shop space is 8 meters, more than the width. If the shop space is 48 square meters, what are the dimensions of the space? So this is application question. The length of a shop space is 8 meters, more than the width. If the shop space is 48 square meters, what are the dimensions of the space? So it means you must understand that when we are talking about length and breadth, and we have been given the shop space as 48 square meters, that is the area of the shop. The area of the shop. And we know that area is given by what? Is equal to what? The length times the breadth. Don't forget the breadth is the same as the width. So area is equal to length times width, or length times breadth. Now, the question is telling us that the length is 8 meters longer than the breadth or the width. That's what the question is saying. The length is 8 meters more than the width, but the question did not tell us the width. And so for that matter, we need to represent, I've stated in earlier discussions that in mathematics, anywhere that you don't know something, you don't know the value of something, you represent it by an alphabet.
Yeah.
which we call in mathematics variable. And so the question has given us the length, but it has not given us the width. And so we will represent the width of the subspace by any variable. I have chosen to use x meters to represent the width. So the length of the width, the width of the subspace is given by what? X meters. So I said, let x meters be the width of the subspace. So the width of the subspace is equal to x meters. Now that we know the width of the subspace to be x meters, and the question is telling us that the length is 8 meters more than the width. Now we are saying that the width is x meters, and the question says the length is 8 meters more than it. So what will be the length of the subspace? It's going to be what? X plus 8 meters. Why? Because the width, we are saying that the width is x meters. Now, if the width is x meters and the length is 8 meters more than the width, it's just a matter of adding the 8 to the x to get the length of the subspace. I don't know if you agree with me. Do you understand that point?
Yes.
Are you sure? All right.
Yes.
So
yes, we do.
Once you let x be the width of the subspace, and the question says the length is 8 meters more than the width, and now the width we are saying is x, it means the length is 8 plus the width. That is x plus 8 meters. Once we do that, now we know the two dimensions. And so we substitute that into the area of a square. Okay, into the area of a square. And so we know that area is equal to length times width. And for that matter, the length will be what? X plus 8 times the width, which is x. So x plus 8 times x. That is what you see here. Do you agree to that?
Yes.
Yes.
Yes, sir.
Yes, sir.
So we are coming out with a quadratic expression. But don't forget that the question has given you the area, the value of the area, the dimension of the area. It says if the subspace is 48 square meters, and so it means we know the area. The area is 48 square meters. So in place of area, we will write 48. So now we know that 48, which is the area, is equal to the length, which is x plus 8, times the width, which is x. Then we'll expand the bracket, remove the bracket by expanding it. So, like I said earlier, 48 is equal to x plus 8 times x is the same as x plus 8 times x equal to 48. So that is what I have written here. These two expressions are not different. They are the same. Do you agree to that?
Yes. Yes.
Okay.
Yes.
So now expand the bracket. We'll remove the bracket. But now I believe you all know how to expand or remove a bracket. So this x, which is outside the bracket, will multiply everything inside the bracket. So we have x times x, that gives us x squared, plus the same x multiplying 8. That gives us 8x. And that is equal to 48. So you see that we have arrived at our quadratic expression. Are we all on the same page? Are we okay with
Yes, sir.
that? Then we have to factorize. But before that, we need to make sure that we equate it to 0. And so we have to move the 48 from its current location, let it cross the equal sign to join x squared plus 8x. So that is the movement. Now it is positive at its current location. Once it crosses the equal sign, it becomes negative. Then we equate to 0. So that is what you see. So now you can see our quadratic equation clearly. Then we'll follow the same approach that we used in this first example. Factorize this. So what is the coefficient of x squared here?
1.
Negative.
It's 1.
1.
Yeah.
Let's be careful. Who was mentioning negative 1? Where did you see negative 1?
1.
Relax. So the coefficient of x squared is positive 1. What is the coefficient of x?
8.
Positive 8. Positive 8.
Positive 8. And then we have the product term. Now, who remembers how we have to start? What to do before we start the factorization? What do we do first?
You
You have to look for two numbers. When you add up, you get.
No. Before you get there.
You multiply the coefficient of x.
Is it the coefficient of x?
The x squared times the 48.
Yes. So we are going to multiply the coefficient of x squared, which we said is positive 1. Multiply that positive 1 by the product term, which is negative 48. So positive 1 times negative 48 will give us negative 48. So we keep it in memory. Don't write it. We keep it in memory.
Okay.
So we know what negative 48. Then we will look for two numbers that when we multiply those two numbers, we will get negative 48. But when we add those same two numbers, you get the sum term, we get positive 8. What are those two numbers?
Negative 4 and positive 12.
Yeah.
Negative 4 and positive 12. That's correct. Because negative 4 times positive 12 will give us negative 48. The same negative 4 plus positive 12 will give us positive 8, which is the sum term. So that is correct. Once we get that correctly, then we'll attach x to those two numbers. We attach x to negative 4 and attach x to positive 12. Then we'll come back to this same expression. Take out 8x and put negative 4 plus 12x, negative 4x plus 12x in place of what? 8x. Okay. So please write that step. I don't have that step yet, so write it. That's why I told you from the beginning. Have your pen and papers and whatever and your calculators by you, because I can put every step on the slide. So write that expression. So that expression will now be what? X squared. So write as I say. That will be x squared minus 4x plus 12x minus 48 is equal to 0. Are we there?
Yes, sir.
Is everybody with us?
Yes,
Right.
yes.
So now, what you have written there, put them into two pairs of brackets. Those on the left-hand side of the equation sign. So the first two, you put the first two into one bracket and the last two in one bracket. Have you done that?
Yes, sir.
Now let's factorize. So let's take the first bracket. What is common there? The first bracket should contain x squared minus 4x. So what is common to that bracket? Sorry, x squared minus 4x. What is common to that?
X. It's X.
It's X.
So x is common. So we take x out. Open another bracket, put x outside that bracket. And then use the x to divide x squared. So x squared divided by x. The answer you get, write it in the bracket. What do you get?
X.
X. So write the x in the bracket. Use the same thing, divide negative 4x. So negative 4x divided by x. What do you have?
Negative 4.
Negative 4. So write that one also in the bracket. So we are going to get x out into bracket x minus 4.
Minus 4.
Is that what?
Yes,
is that what
sir.
you have?
Yes.
Yes.
Nice one. So now we go to the next bracket. We do the same thing. What is common to that bracket? That bracket should contain positive 12x minus 48. What is common there?
Yes.
12.
So
Yeah.
positive 12.
Positive 12.
Correct. Good. So write as 12 and then open bracket.
48.
Now we are going to use the positive 12 to divide positive 12x. So positive 12x divided by 12, what do we have?
X. Positive X.
X.
So put the positive x inside that bracket. We divide negative 48 by positive 12. What do we have?
Negative 4.
Negative 4. So put the negative 4 there.
What you say?
Now compare the two brackets. Are the answers
They
different?
They are the same.
No, they are the same.
They are the same. Once they are the same, it means we are on the right path. So equate to 0. Now, since the answers in the two brackets are the same, pick one of them and copy it down there. Then open another bracket and put those outside two inside the second bracket and equate to 0. So now somebody should read what he or she has to our hearing.
So we have
X minus 4.
4 and negative 12.
Come again.
The answer is 4 and negative 12.
No, don't confuse us. Hey, are you that wicked?
Sir,
This man is very, very wicked.
You get X
Minus 4
and 8.
Yes.
It will be 4 and 8. X should be equal to 4 and 8.
People are very wicked lecturers.
Let me expand it.
You don't want us to. We are going step by step.
Okay.
As I read what you have in your bracket, that stage, what do you have?
X minus 4 equal to 0. And X plus 12 equal to 0.
Yes.
You have still. I wanted to know what you have there. The stage we reach.
So we have
bracket. The next step.
One bracket. So say X bracket.
Hello.
X into bracket.
Who is talking? Yes.
Sir, it's me. Answer. Emmanuel answer. Can I speak?
Yeah, go ahead.
Yeah, into bracket, the first bracket is X minus 4.
Yes.
Into another bracket, 12 minus 4, all equal to 0.
That is Hey, do you have 12 minus 4?
No, X minus 12.
No. Minus
No.
4.
Bracket
No.
open x minus 4
Yes.
and x plus
Equals
12
0.
equals to 0.
X minus 4,
4
then
under bracket x plus 12
X
equals to
X
0.
plus 12
12
equals
equals to
0.
0.
Is that not it?
Yes,
Or
it
you
is.
all have?
Yes.
Good.
Yes, we have it.
Good. So it is now that you take each bracket and equate to 0 and make x the subject. So that is this stage. Now let's come back to the slide. So this is what we are all supposed to get. That's not what you have. The position of the bracket doesn't matter. The figures inside are okay. You have x minus 4 first,
yes,
then
before
x
X
plus
plus
12
12.
second.
Yes, sir.
It's the same. It's the same thing. It doesn't change anything. So that's equal to 0. Then you take each bracket, equate to 0, and make x the subject. Then in the end, you are getting x equals negative 12 and x equals 4 as your answers. Is that not it?
Yes,
Yes. Are we all on the same page?
Yes, please.
Thank God it's Saturday. So now you could see clearly that the dimension of a shop cannot be zero, cannot be negative. Do we have a negative dimension of a shop?
No.
No.
So we'll discard the negative answer and use the positive one. So our answer, so it means the width. We started by saying that we let x be the width of the shop. And for that matter, now that we know the value of x to be 4, we will now conclude that the width cannot be negative. That's also this one we have rejected the negative answer and we have taken the positive. So the width is what? 4 meters. Now that the width is 4 meters, what is the length? You remember we said the length is x plus what? 8. Now we know x to be 4. So 4 plus 8 will give us
12.
12. And for that matter, the dimension of the shop is 4 by 12 meters. That's all. Any question? So you see, it is interesting if you practice this thing. It's not difficult. Once you understand, mathematics, I always say, is the easiest course. I sleep and wake up and take my notes and come and teach. If you give me any reading course, I can teach. Because for mathematics, if it is 1, it is 1. If it is 2, it is 2. The only thing is to get the understanding, to get the concept. Once you get the concept, and it is systematic, step by step. That is why when some people were skipping to tell us the answer, I said, no, they want to be wicked lecturers. We don't like that. Let's move step by step. If you follow the step, so if you want to go and learn and go to practice, just first take the example that we have solved in class. Follow the steps and see if you can solve it. Once you follow the step and you solve and compare and your answer is correct, you can set the question, your own question. Just copy the words in my example and change the figures and solve. That is all. Okay? So if I want to give you an examination question, I can just come back to the same question. I can pick the same example that I have given you and only change the figures. That's all. I've got a new question, new examination question for you. Simple. So you don't read. That's what I said. You don't just read. You read and work with your hands, fingers. If you practice, you come to love mathematics. Mathematics is not difficult at all. But if you don't practice, you think you go and leave it there, you read. I'm sorry, it will not work. So that is that. If there's any question, please bring it up and let's deal with it before we move on. Yes. Is there no question?
It
Yeah, go
seems
ahead.
to me that once you get the two numbers that would give you the product and the sum, that should be your final answer. I mean, for the two examples you gave, that's how it seems. Is that always the case?
Yes, as mathematicians and statisticians and researchers, we don't just conclude. Yes, you are concluding based on the two examples that we have solved, but we don't just use two examples. Maybe we have to do a lot more to confirm. That is by way of research. That's how we do research. So yes, I like your observation. That is a nice one. But I will not say yes or no until we observe more of that to be sure that that is how it is. But even in that case, in any case, if that is how it is, you can just get it and just go and conclude that that's the answer. Because in awarding the marks, the final answer is always only 1 mark. So if you just keep and you go and just write that because you have seen this, that is the answer, you lose the answers for all the steps. Mathematics, we award the marks for the various steps. So, well, that can be a guide for you that you know the answer down, but follow the steps. So if you don't do that, you lose a chunk of the marks and you go and get the last one to be 1. And even we will not even give you that one because we will feel that you giraffed, you stretch your neck and saw somebody and you just answered it. We mark, we have what we call, when you see us marking and we put that M1, A1, blah, blah, blah. If anytime your M, you score 0 for M, it means your A should also be, the answer must also be 0. So that is the step-by-step marking. So if you skip a step and I don't see that one, I put M0. I give you 0 for M. It means whether your answer is correct or not, is 0. So follow the steps. But I like your observation. That is perfect. It can be your guide. So that's good. Please, any other thing?
Yes, sir. Sir, is it always the case that one will be negative, one will be positive?
It cannot always be the case.
Okay.
It is not always the case at all. You may have some that will all be negative or all positive. Okay. So it is not the case. Any
Sir,
other thing?
can you go back to the slide before this one?
All right.
Where you see the last line, where you said the coefficient of x squared.
Yeah.
So it is assumed that there's 1 in front of the x. Is it always the case that 1, or there could be 2x squared?
There could be 2x squared. Okay. There could be any number there. But once you don't see a number there, it means it is 1. But if
so whatever number is there,
please come again.
I said whatever number is there, you multiply it. You see this one because it was 1.
The point.
Exactly we multiply that we keep it in our mind.
Yes.
So supposing it was 2, we'll multiply and write the figure down.
Yes. Okay. You keep the figure in memory. You don't write it down. You keep it in memory and use it.
Whatever figure is there, you don't write it down.
Yeah, you don't write it. You saw that in this example, we didn't write it. We didn't write the negative 48 anywhere. You keep it in your memory and make use of it. But if you think you cannot keep it, you may use your pencil to write it somewhere. When you finish using it, you clean it. So assuming it was 2x squared. So you would have multiplied 2 by negative 48. So you would have gotten negative 96.
Yes.
So you keep it in memory and use it. And if you cannot keep it in memory, you use your pencil to write it somewhere. When you finish using it, you clean it.
Okay.
That all right?
Yes, sir.
Any other thing? Okay. Silence means consent. Thank God it's Saturday. It is raining over here too. I don't know if it is raining at every place in Ghana.
Nice. Everywhere it's raining.
Oh, that's right. Yeah, it's
I
sunny.
guess so.
Nice.
Oh,
It's
okay.
raining.
That's fine.
Not raining.
Okay, that's fine. I'm on campus. It is raining here. Okay, so let's take the next one. So finish with the factorization method. Now we want to come and use the almighty formula approach. Now you could see in the corner that I use some red markings there. Previously, I took them through how to prove the almighty formula, but it's not necessary now, so I'll leave it. Let's just know how to use the formula, and that will be fine. So this is the quadratic formula, which we call the almighty formula. It is up to you to know how to, it is up to me to help you know how to apply this formula in solving problems. So we are saying that for a quadratic expression, ax squared plus bx plus c equals 0, this is a quadratic equation. And so if we want to solve for x using the quadratic formula, this is the formula to use. X is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, so when the question is given to you, all you need to do is to find the value of a from the question, find the value of b from the question, and find the value of c from the question, and then you come and substitute into this formula and you solve. That's all. Okay, let's take an example. You are to solve for x in this problem. Okay, so when you come to this problem, the first thing to do is to identify your a, b, and c. Okay, so following the expression here, a is the coefficient of x squared. And so if you come to this question, a is what? 4. So that is a equals 4. If you go to the expression again, b is the coefficient of x. So if you come to this expression, b is equal to what? Negative 17. Do you agree?
Yes.
Yes.
If you go to this expression again, c is the last term before the equal sign. So let's go to this question. C is what? 15. So that is it. So that is all. If you are able to identify the variables, then you just go and substitute into the formula and then go. So now we come and substitute into this formula. So we are going to say x is equal to negative b. Don't forget there is already a negative in the formula. And our b is also coming with a negative. I don't know if you have seen it. The formula already has a negative. And our value for b is also coming with a negative. Yes. So, you see this. In the typing here, there is an error. The negative for the b didn't come. That's what I wrote here. So it should be like this. Negative into bracket, negative 17. Have you seen it? Hello?
Yes, sir, we are here.
Yeah. So b is negative 17. So if you follow the formula is negative b. So you are going to get negative of negative 17. Again, pop, and that becomes what? Positive 17. That's why you are seeing positive 17 here. Are you saying that?
Yes, sir.
Some people are quiet.
Sir, we are just concentrating. We are concentrating.
Okay. So I just want you to understand that. So always remember the formula already has a negative. So if you bring a negative value for B, it will change the whole thing to positive. So that is how come you see positive 17 here. Plus or minus the square root of what? The formula had B squared. So this time the B has no negative. But our value for B is coming with a negative. So that's going to be negative 17 squared. That's what I wrote here, if you can see the red ink. So it should be negative 17 all squared. Minus, we are just following the formula. So this one is a formula work. You follow the formula. So minus, so you also copy minus. Then 4, so you also copy the 4 times A. And our A is also 4. So times 4. Times C. And our C is 15. So times 15. So all divided by 2A. Write the 2 times A, and the A is 4. So 2 times A, so 2 times 4. That gives us the 8 here. So that is the 8 you see there. And this negative 17 becomes positive 17, plus or minus. Now you take the square of 17. You take the square of 17, it gives you 289. So that's what you see here. Minus 4 times 4 times 15. 4 times 4 is 16. 16 times 15 will give you 240. All divided by what? 8. So that's the 8 here. And you subtract 240 from 289. So if you have your calculators there, you can be subtracting. If you do that, you are getting 49, square root of 49. Okay? In the square root sign, the left is 49. You now take the square root of 49, and that will give you what? 7. So the answer is going to be 17 plus or minus 7. Now, the plus or minus tells you that you are going to get 2 answers for X. One for the positive side and one for the negative side. Are we on the same page?
Please.
Hello? Hello? Can you hear me?
Yes.
That's how we can hear you, sir.
So are we on the same page?
Yes, sir.
Yes, sir.
Good.
Yeah, somehow.
So we have X. Okay, let me go back and start. So we have to solve for X in 4x squared minus 17x plus 15 equals 0 using the almighty formula, or what we call the quadratic formula. And I said the only thing is for you to identify your A value, your B value, and the C values. Okay, so if you follow the formula, you have, let me go back to this. You follow this expression. So A is the coefficient of x squared. So let's come to the question and identify our A. Now, here we have 4x squared. So the coefficient of x squared is the A. So that is 4. So it means our A is 4. Okay. Then let's see. Then we have bx. B is the coefficient of x. So let's go to the question and identify our B. So we have negative 17x. So the coefficient of x here is negative 17. So that is our B. So our B is what? Negative 17. That's what I've written here. Then let's look for our C. If you follow the expression, our C is the last term before the equal sign. So let's see the question. Our C is 15. C is equal to. Once you are able to identify all this, that is all. The rest is the formula where just go to the formula where you see A, you put the value 4 there. Where you see B, you put the value negative 17 there. Where you see C, you put the value 15 there. That's all. And then you simplify. So when we came, we said x is equal to this. So x is equal to negative. Don't forget there's already a negative there. So you are just following the formula and you are copying it. Then where there is the value, you have to put the value, you put the value there. Copy negative. So that's the negative. Then the value of b. The value of b is negative 17. There was an error here. That's why I used the pen. Okay. So to write the negative 17 there. So you see negative changes the negative to what? Positive.
Positive.
So that's how come you see 17 here. Are we okay with that?
Yes. Yes.
Yes, sir.
Then you follow plus or minus. So you also copy the plus or minus. Then the square root, you copy the square root. Then inside the square root, you have b squared.
Right.
So b squared, go for the value of, is somebody talking to me? All right. So you have b squared. So pick the b value and square it. So that's what you see, negative 17 squared. There was still the omission of the negative here. So that's what I wrote here, negative 17. You can see the red ink, negative 17 squared. Then you follow the formula minus. So you copy minus. 4, you copy 4. Times a. Now what is the value of a? So you bring it. A is 4, also 4. So you put 4 there. Times c. So you also go and look for the value of c and put it there. It is 15. So you multiply by 15. All divided by 2 times a. Now 2 times a is 4. So 2 times 4, that's 8. So that's what you see here. Are we okay up to that stage?
Yes, sir.
Yes, sir.
Now the rest is for you to simplify. So let's simplify. So we have 17 s. Now we have to deal with what is within the square root. Now you take your calculator and find negative 17 squared. If you do that, you get 289. Minus 4 times 4 will give you 16. 16 times 15 will give you 240, sorry. So that's what you have here. Then it is minus. So still within the square root sign, you simplify 289 minus 240. And that is giving you square root of 49. That's what you see here. Then you now take the square root of 49. That will give you what? 7. So that is what we are seeing here. So we have 17 plus or minus 7, all divided by 8. Now, I was telling you that once you see plus or minus, it means there are 2 answers. So you take the first one with the positive, and then you go and take the second one with the negative. So the first one will be x being equal to what? 17 plus 7 divided by 8. So that's what you see. Or you take the second one, that will also be x being equal to what? 17 minus 7 divided by 8. That's what you see. You have 2 answers. So 17 plus 7 will give you 24. 24 divided by 8, that gives you 3. Or the second one, 17 minus 7 will give you 10. 10 divided by 8 will give you 1.25. So these are your 2 answers. X is equal to 3 or x is 1.25. Are we okay with that?
Yes. Very, very okay.
So, did I hear not very okay?
Very okay.
Is that what I heard?
Yes, please. Very okay.
Oh, okay. All right. Then we can continue. So that is that. Now we want to look at the application side of this. Then I think when we finish with the application side, we have to end it there. It's even almost 12. We are supposed to close at 12:30, yes, right? But the way I look at the responses, if I add more, the little we have understood will vanish. So we'll look at the application and then we may close. If that ends the slide, let me see. Yes, that ends the slide. So even this application, okay, let's look at it and see. But then also where now let's look at this application. The board of directors of Cheesy Company Limited agrees to redeem some of its bonds in 2 years. At that time, 1,102,500 cedis will be required for the redemption. Let us suppose that 1 million is presently set aside. At what compound annual rate of interest will this application question, I'll leave it because there is a simple formula that we'll be looking at when we look at interest. So I'll leave this so that we'll go and use that simple when we are looking at interest. We'll use this thing there so that it will be easier. I don't want to, so let me leave it. So ladies and gentlemen, let's end it here. If there's any question on what we have done today, you can bring it up. If there's no question, call it a session and see you next week. So come out with your concerns and let's address for close. I will not add any other thing for anybody to be more confused. I don't want any problem. I don't want hell to break loose over here. Alinko, I don't know whether it's Mr. or Madam or Mrs.
Sir, good afternoon. Please, I don't know if maybe there are any other examples that maybe you can put on board for us to try our hands on, just to make us
all right. So you write
more good at that.
Right. Yes. Write this question, and you are going to use both approaches to solve, both formulas. We have used both methods. So write this question. Solve x squared plus 3x minus I said x squared plus 3x, yes. Right? Minus, what should I put there? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 3, 3, 3. Minus 4. Yes, that's nice. Minus 4 is equal to 3. So using both factorization and quadratic formula methods. I hope you've all got it right.
Okay.
If you ask me to repeat, I may not get the figures because I just set it off head. Should I repeat?
Oh, that is fine.
Okay. Have you all gotten the question? I said solve x squared plus 3x minus 4 equals 0 using both factorization and quadratic formula methods.
Yeah. Yes.
Right. I'm going to put the slides. I'm going to send the slides to you so that you can follow and practice. Any other thing?
Yes, I have a concern.
Yeah, raise it.
I want to find out if it will not be better for you to expose her to, you see the final, the application question and the quadratic equation. Would it not be better for you to expose us to the two methods that you talked about so that the individual objective on the course will be achieved?
I don't get your question. You said I should expose you to which two methods?
What I mean is that, you see, you were about solving a question, this particular question.
Yes.
But then you suggested that there will be a
You want us
simpler.
to solve it. You want us to
Yes,
solve it. Is that it?
Yes, that is what I'm trying to say.
I don't have any problem, provided you are ready to absorb it. I don't have any problem.
Yes.
But as a professional, I felt that since most of you are anti-mathematics people, the more I pile on you, the more my work becomes cost 90. So as a professional, once I sense such danger, I need to pause. That is why I was pausing. But if you insist that you are ready to absorb, I don't have any problem.
Let's go by your professional.
Madam.
I said, please, some of us will be glad if we pause here.
All right.
Please, sir, please, let's work with your professionalism.
All right.
Thank you.
A lot of us will be glad if you can pause here.
All right. And the problem to EB. Definitely, I travel. Okay, come on, no, that's a question. All right. All right. So, since you agree with my professional convention, we can pause here. But if there's any other question, you can raise any other concern, please raise it before we go. Are there any other concerns? All right, then.
So, sir, please, so when we did the quadratic equations, that was when we used the two formulas. We have the factorization and then the one you call the almighty formula.
Yeah.
So that is what we are supposed to use. Those two formulas, the factorization and the almighty. Those two formulas is what we are supposed to use to solve the question you just gave us, right?
Exactly.
Okay, that's fine.
Please, any other thing? All right. Then we say, thank God it's Saturday. And then see you next week.
Thank you, Thank you, dogs.
Thank you.
Enjoy your
weekend. Enjoy your Valentine.
Thank you. Same to you.
So thank you very
much. Welcome.
It must be grateful.
Yeah, when can we get the slides?
Yeah, I'm going to send it to you. Get it.
Okay.
I'll send it right away.
Yes, sir.
Come. Sorry.
Please, is Papa Sam still on the line?
line.
I saw you were recording. If you can share, because these people, if you wait for them, sometimes it takes a while for them to share.
Okay.
I'm sure they do editing. They edit and take out the ones they think is not necessary.
Okay, but
So before they
I copied in the middle of the session, so let me try and see if I can share it.
Okay.
Thank you very much. Please, is there any page for the class? So should in case when there's any information you can share or something?
Are you new on this platform? We have a
I'm not
WhatsApp
new.
page.
I'm not. Is that what? I'm not new.
We have a WhatsApp page, or
No offense, please. No offense. It's just a question.
Yes, brother. There's a
Don't
WhatsApp page.
don't get
MSc
offended.
Finance January intake.
Oh, okay.
Okay, some of us we are new. We are just
We
joining
understand.
today.
We understand.
oh, okay. There's a WhatsApp page for I think both MSc Finance, the whole the whole of, and then the January
2 cohorts,
2 years.
January and last year, sure.
Last year, yes.
So please, you can add us.
Okay, so is there any link to add up or probably?
So you are not in any of the WhatsApp pages. But are you on the IC? Is it the ICDC?
Yeah, I'm on the main page. I'm on the main page.
Yes. The WhatsApp pages were posted there for us to join. So go there and go and check the messages. It's there. The links are there all over.
Okay.
Just take your time. Just take your time. You see everything there.
The link, yes. When you go there, and please, I would advise that we follow the pages so that some of these.
We'll surely do that.
So most of us, I'm sure we are busy, but when you come there, follow whatever is there, the conversation and all that. You understand?
Yeah, we do.
Just take a little time to follow what has happened on the platform so that you can follow some of these. It's very important. As we want to think sometimes we need to dedicate a little bit of time to follow what goes on there.
All right. Thank you very much.
You're always welcome.